S. Chan presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
In this part of the video, we will be learning about integrals. Integrals are the important or a basic part in which integrals are an important topic in case of a business mathematics subject, and we'll be learning that same in this part of the video.
If you want to study this topic in detail, refer to these books from S. Chan Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia. The course that we are covering is business mathematics, and so the topic is integrals, and firstly we'll be understanding about the different formulas which are associated with integrals, and then we will be looking at certain application of integrals in business mathematics. So we'll be looking at the particular formulas, and the first formula is integral x raised to the power n dx. So every integral is associated with a dx quantity, which is indicating that it is with respect to which variable. So it is with respect to x. So x raised to the power n is having the formula x raised to the power n plus 1 over n plus 1. The second thing is 1 over x dx. That means it has a formula of log x. The third thing is e raised to the power x integral. So it would be e raised to the power x only, and every aspect is related to a constant, and we need to add that constant to it. That indicates that we are doing a case of an indefinite integral. Then a raised to the power x dx integral is there. So the formula is a raised to the power x over log x plus c. So in every formula, this plus c part is the integral part of this formula. Because it do not have any limits, so we are not confirmed about the fixed value. So if it has fixed value, then this constants may not occur, but it is having an indefinite value because the limits of the integrals are not there. That's why we will be adding a constant to it. Then we have certain integral formulas, like the integral formulas for trigonometry. So we have sin x's integral, that would be minus cos x. The integral of cos x, it would be sin x. Integral of sec square x is tan x. CSC indicates this cosec square x dx, so that would be minus cot x. Sec x tan x is having a formula of sec x, that is the reverse of the derivatives. So cosec x cot x formula is minus cosec x. Sec x integral is log sec x plus tan x. The integral of cosec x is log cosec x minus cot x. So all these formulas would be having a constant with the other half, and that constant would indicate that there is no limit of the integrals. So these are the basic formulas. The integral of tan x is log sec x, cot x formula is log sin x. Sine hyperbolic is having an integral formula of cos hyperbolic is having a formula of sine hyperbolic dx, and when we have 1 over x square plus a square, that has a formula related to tan inverse. So you have 1 over a tan inverse x over a, which is the formula of this integral, and the next integral, which is with root 1 over root a square minus x square, that has a formula of sine inverse x by a. So these are the basic formulas that are required before understanding the concept of the application portion. Another example or another formula is 1 over x square minus a square, that is 1 upon 2a log x minus a over x plus a, and if it is with root, then log x plus having the same bracket or the same part. So log x plus under root x square plus a square, or if it is with minus, so x square minus a square. Now, what strategy we look for when we are doing these integration concepts or integrating integration aspects into the business. The one thing is, when we are equipped with all these formulas, we have to prepare a strategy. Like the strategy is, we need to simplify the integrand if possible. So if we have a particular set of particular elements, and those elements are maybe complex or segregated in terms of numerous number of elements. So first step is to simplify that particular integrand if possible. Then the second thing is, we look for obvious substitutions. We look for certain substitution of the elements together in the integrand, so that that would be simplified, that particular aspect would be simplified. And third, we classify the integrand according to the form, and we need to try again to get a particular solution. This is a particular aspect or a strategy for doing the integration. Let's say whenever we want to simplify the integrand, and the algebraic manipulations or the trigonometric identities are there in terms of your integrand, and that is required to be simplified. So we need to look for the breakage of those trigonometric entities, and then we try to integrate it with the portion, so that to get the obvious solutions. Let's have a look at certain examples of what I am telling to simplify the particular aspect. Let's say we are given with these two numbers or these two algebraic expressions, and we want to get the integral of these two products. So for the products, we don't have a rule that is already there in case of derivatives or in case of differentiations. So for that, we'll look for simplifications. So we'll multiply this root x with 1. We'll get root x, and root x multiplied by root x is x. Now we get a particular algebraic expression that was simplified, and we have the integral of these two different variables. So we have an integral of root x, that is x raised to the power half. So the integral of this is x raised to the power 3 by 2 over 3 by 2. Plus if we have x, so we can use that formula, which is x raised to the power n plus 1 over n plus 1. So x square by 2 plus c will be the final result of that particular integral. And if it is of integration type, like let's say tan theta over sec square theta, so we need to simplify it into simpler formulas, like tan theta is having the formula of sine divided by cos, and sec square theta is having a formula 1 by cos square theta. So on simplification, we'll get this result, which may lead to a formula which is of sine 2 theta when we multiply and divide by 2. So half is to be multiplied, and integral of sine 2 theta comes into the picture. So integral of sine is, we know that the integral of sine is minus cos 2 theta over 2 as per the chain rule for integrals, and then half is already there. So this would be the final answer after breaking it into a simpler form. And let's say we have this integral in which sine plus cos whole square is there. So we just need to open up the whole square and look for a simpler formula, like sine square plus cos square. Sine square plus cos square is having an identity 1, and we have 2 sine x cos x. That can be termed, or that can be clubbed into a particular identity of sine 2x. So one is having an integral with dx, that is x, and we need to integrate this sine 2x with dx. So the integral of sine 2x would be minus cos 2x over 2, and that would be added to x. So that would get the final result. So the second stage that we try while solving those integrands is substitution way. Let's say we have this particular problem, which is x over x square minus 1. And after seeing at that particular requirement that the denominator part is a derivative of the numerator part. So what we will do, we'll try to substitute the denominator as another variable, let's say t. So here we will substitute x square minus 1 as t, and then we will derivate it. So 2x is the derivative of x square, and additionally dx will come, and on the other side it would be dt. That means x dx would be equal to dt over 2, so that we can write x dx as dt over 2 and we will get the denominator as t. So we have an integral which is predefined, and I have told you the formula also, 1 over x dx or 1 over t dt, that is having the formula of log t plus c. So t can be substituted again here. So log x square minus 1 plus c would be the formula, would be the final result of this particular expression. So we'll look for substitution instead of using the method of partial fractions. Then if it has some trigonometric functions, we'll look for the divisions into the simpler form and then try to find out the obvious results. The third case is integral by parts, in which we have to integrate some products of two different numbers which are having the values, let's say x sine x, or x into e raised to the power x, or x into log x, or we just want to derivate, or we just want to integrate log x. So for that we have a procedure which is isolate, that can be written as isolate. This is used for giving a preference to a particular you can say a particular function. So this I indicates the inverse function, L indicates the logarithmic function, log function, A indicates the arithmetic function, arithmetic, and this T indicates the trigonometric function, trigonometric, and EX indicates the exponential function. Let's say you have to integrate x and sin x. So you have to give a preference of number 1 and number 2 to these two different functions. So I have told you the preference order, which is isolate. That means this x indicates the arithmetic function. So this x is the first part that is there, and sin x indicates the trigonometric part which is there. So sin x can be treated as the second number, can be treated on the second slot, and x can be treated on the first slot. Additionally, if I want, let's say, x log x integral value, so for that log x is the first preference number and arithmetic is the next preferred number, next preferred you can say the function. So log x is the first function that is to be used, and this one is the second function that is to be used. So this is the case with going for integral by parts. Before going to learn a solution which is related to finding out the solution by parts, we have to at least do it like this. Then we need to understand the procedure of this by parts. So we have this first and second function together and we want to integrate them. So the procedure is, we have this first function as it is and we have the integral of this second function, minus we have a big integral, then the derivative of the first function into we have the integral of the second function, and overall we have to integrate it with this big integral function. Let's say for an example we have x sin x. So as I've told you, through isolate we have this first function which is arithmetic and sin x is a second function. So we want to integrate it. As per the formula of this by parts, we have to write it like this, that the first function will remain same and we have to write the integral of the second, which is integral of sin x, that is minus cos x. Minus we have a big integral in which we have to write the derivative of the first, which is the derivative of x as 1, and the integral of the second, which is minus cos x. So I have written minus cos x dx. Then we have integral still left, and we have minus x cos x. We have minus x cos x and plus integral of cos x. So integral of cos x is sin x. We have to write sin x here, and finally you have to mention c. So this is the final result that is obtained through the substitution method. So substitution method is the method which says that there are the two functions which are there in products, and we need to apply this formula to solve them further. Then let's say you have some trigonometric function, and that trigonometric function is required to be solved. So how to solve it? Like dx over 1 minus cos x is mentioned. So I can solve it by multiplying it with the same set of you can say opposite part, which is 1 minus cos x. I need to multiply and divide by the rationalizing factor, which is 1 plus cos x over 1 plus cos x. So I'll get a function which is 1 plus cos x on the numerator, and in the denominator we'll get this 1 minus cos square x. So 1 minus cos square x is sin square x as per the general trigonometric formula, and we need to separate it out. So we'll get cos x square x here, and cos over sin square x would be cot x and cosec x. So we have the integral of cos x square x, we have the integral of cosec x and cot x as per the formula that I have already told you. So we can solve these examples with the help of the general solutions. Let's say for an instance we have this integral that is required to be solved, that is tan square x sec x dx, and that would be a challenging integral because we don't have products formula, and both of them are the same function which is a trigonometric function. So how to solve it? We have to replace this tan square x by a formula which is sec square x minus 1. So when I multiply or replace this with the formula which is sec square x minus 1 and multiply sec x with it, I'll get sec cube x minus sec x, and then I can integrate it easily with the help of that general formula that is already there. So we stop here for a short break. After coming back from the break, we will look for certain examples in which we will try to solve certain problems with the help of integrals.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy, and I am Anmol Bhatia. Before going to the break, we have learned certain basic concepts which are related to integrals, some formulas and some aspects in which we have learnt about certain cases of substitution method and certain cases of by parts and some integrals which are related to the trigonometry. Now in this part we will be learning some of the examples, and without wasting much time, let's look at those examples. So we have example number 1 here, which says that we have to integrate tan cube x over cos cube x, and we have to integrate it with respect to x. We don't have any formula for this, for the division. So for this, what we will do, we'll open it up. We'll try to open this tan in terms of sine and cos. So this tan cube x is open in terms of sine and cos. It would lead to sine cube x over cos cube x, and it has this cos cube x already there. So this would lead to sine cube x in the numerator and cos raised to the power 6x in the denominator. Now we have to simplify it more as per the steps that we have seen previously. So sine cube x can be broken up into the elements like sine square x into sine x. So I have written it as 1 minus cos square x into sine x over cos raised to the power 6x. Now we have seen the substitution method, so we need to substitute this cos x as maybe t. So we need to substitute cos x as t or u. Then we have to derivate it, which is minus sin x dx equals to du. So sin x dx would be minus du as per this formula or as per this calculation, and in terms of cos x we need to substitute u. So minus is multiplied by this equation, so you will get u square minus 1 over u raised to the power 6, and u raised to the power 6 is to be divided individually with these elements. We will get u raised to the power minus 4 and u raised to the power minus 6. Now we have the general formula for this u raised to the power minus 4, which is u raised to the power minus 3 over minus 3, because the general formula is x raised to the power n's case. So x raised to the power n plus 1 over n plus 1 minus u raised to the power minus 5 over minus 5, and you have plus c. Again you will substitute u as cos x, or you can write here undoubtedly that where u equals to cos x, you can write it here also. So this is the example number first. The second example is e raised to the power root x dx. So how can we solve this e raised to the power root x dx? For this we have to substitute something, like for root x we can write it as u, and in order to remove this root we can square it up. So x is equals to u square, and then we go for the derivative. So the derivative of x is dx, and for the derivative of u square is 2u du. So putting all these values together, so we'll get e raised to the power u, and dx is 2u du. So 2u du. So ultimately this integral will become this part. Now how can I solve this part? We'll do the usage of by parts, because these two are the two different functions and they are in the product form. So what we will do, we will use a first function, which is the arithmetic function, and use this as a second function, and then we'll use the integral by parts to solve this particular example. So integral by parts I have already told you in the part before going to the break. So you can apply that concept and solve that particular thing easily. Now coming to the third concept or third example, which is dx over x root log x, and in this, as the question is indicating that you have x and you have log x values. So what can be done? You know that the derivative of log x is 1 by x. So we'll try to substitute it. So we will use this log x, and we will substitute this log x as t. So the derivative is 1 by x dx, that would be dt. So what we will do, we will combine this dx with x, and we'll write here dx, we'll write here dt, and in the denominator you will get root t, because log x is substituted as t. So we'll try to take it in the numerator, so we'll get t raised to the power minus half dt, and we want to integrate. So t raised to the power minus half dt's integral would be t raised to the power minus half plus 1, that is t raised to the power half over half, and plus c is also the case. So where t is equal to log x, you can write in the final answer. So where t equals to log x, you can write it over here. Then the next thing is integral root 1 minus x over 1 plus x. This is also a kind of problem in which we need to break it into the simpler elements. So for breaking it into the simpler element, we need to divide and multiply by 1 minus root x. So we'll multiply by root 1 minus x over root 1 minus x. So this above, or the numerator's value, will become 1 minus x, and this value will become 1 minus x square with a root. And then what we will do, we'll try to break it into simpler numbers, like 1 over root 1 minus x square is broken or is taken with 1, and this x is taken with another set. Now we have that particular solution that I have already told you during the formulas sessions. So we have 1 over root 1 minus x square as sine inverse x. It has a formula, and x over 1 minus x square can be solved with the help of the substitution method, in which you can easily see that 1 minus x square is a derivative of this x. So we can substitute 1 minus x square as t. So 2x into dx would be dt, and then after solving we'll get this particular result with c. So this is the case. Now we'll look at another example which is related to the biparts, in which we have the case of x into e raised to the power x. So I need to solve this with the help of biparts. So how can I do that? I'll use this I, or I can write this integral as I, and we know that we have to give a preference to a particular function. Like we have to give a preference to this as 1 or this as 1. So as per ILET, we have to give a preference to this first part as the first function and the second part as the second function. So here what we will do, as per the formula says that we have first function. So first function is as it is, it would be same, and we have the integral of the second function, which is e raised to the power x. So integral of e raised to the power x will be e raised to the power x. And then you have a minus with an integral, a big integral. You have the derivative of this first function, which is the derivative of x as 1, and you have the integral of the second part, which is x, and you have to take a dx part with it. So you will solve this particular thing with x into e raised to the power x minus e raised to the power x value is e raised to the power x only, and then you have to write here plus c. That would give you the final result. Additionally, there is one question which is based on the usage of trigonometric function with exponential function. Let's say we have a case of the usage of trigonometric function with an exponential function. Let's say we have this example number 6, we have this case of x sin x. Sorry, not x sin x. So we have a case of e raised to the power x sin x. Here you can see that we have to choose one function as first function, and we have to choose another set of function as a second function. So let's say when we choose sin x as the first function, so first function will remain as it is, and we'll go with the integral of the second function. Then there would be a minus and a derivative of the first function and integral of the second function. Let's say that integral would be in terms of sine only, and then it would be converted in terms of cos, then again in terms of sine, then again in terms of cos. So this cycle goes on. So that particular case, when you will get trigonometric and exponential function, you will put the entire integral as I, and you will try to write, or you will try to use any of the two function as first and second. So any number can be taken as first integral, or any function can be taken as a second function. So what is the basic formula? The formula says that you have first function, which is sin x, into integral of the second, which is e raised to the power x, minus you have a big integral, which is having the derivative of the first function, which is the derivative of sin x as cos x into e raised to the power x. As I have told you that this integral would repeat itself again, because in this also you will have the set which is the integral of the two. So here also you have two different functions, and you need to choose first and the second preference to them. So you can give any number a preference, like we give a preference to this number as first, and we give a preference of other number as 2. So what to write here? Sin x e raised to the power x will remain same, minus I need to integrate this particular integral. So for that I'll write first function which remains same into the integral of this e raised to the power x, which is e raised to the power x, minus you have a big integral, and you have a derivative of this first function, which is the derivative of cos x, that is minus sin x. So we'll write here plus sine x into integral of the second, which is e raised to the power x dx. Now this I will be equal to sine x into e raised to the power x minus cos x into e raised to the power x. Minus and plus is minus. You again have this integral, which is sine x e raised to the power x, and if I integrate it again, I'll get the same repetition, which is of cos x, and then I'll get the same repetition again and again. So I need to remove this integral. So what to do? As I have told you that you need to substitute this particular thing as I. So if this integral e raised to the power x sin x is I, so I can substitute this particular integral as I only. So in place of this particular integral, what I can do, I can no doubt write it as e raised to the power x. So I can write here as I. And I'll be clubbing, or I'll be combining these two i's together. So I and I would be clubbed together, and this particular function would remain same. So sin x e raised to the power x minus e raised to the power x cos x. So this would be 2i, and 2i equals to sin x e raised to the power x minus e raised to the power x cos x. So what you can do here, you can take e raised to the power x as common. You will get sin x minus cos x, and I and I would be 2i, as we have already written. So that would be divided by 2, and you will get plus c here. This is a particular case in which you will get the final result by breaking this into the particular set of elements. And in this particular situation, when you use trigonometric and exponential portion in terms of init, there is no boundation on choosing what function to choose first and what function to choose second. And you just keep in mind that it has to be substituted with I. Otherwise, you will end up nowhere, and the integral will just repeat forever. So with this, we come to an end of this video, in which we learned about the basics of integrals, and also we have seen certain examples which are based on integrals. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.